We're going to evaluate the integral of cosine squared of x. And to do it, we'll need three results. So the first result is a trig identity. Cosine squared of x equals 1/2 times 1 plus cosine of 2x. And the second result we'll need is the integral of cosine of ax dx equals 1 divided by a times the sine of ax plus c, provided this constant a is not 0. And then result number 3 we'll need is the trig identity sine 2x equal to 2 times sine x times cosine x. So to evaluate the integral, our first step is to rewrite this integral as the integral of 1/2 times 1 plus cosine of 2x using trig identity result number 1. And this is 1/2 times the integral of 1 dx plus 1/2 times the integral of cosine of 2x dx. And these are easily done. The first one is just 1/2 x, and the second one by result number 2 is 1/2 in front and then times 1/2 sine of 2x. So this is 1/2 x plus 1/4 times sine of 2x. And now we can use result number 3 to express sine of 2x as 2 sine x cosine x. So the final answer, and this is equal to 1/2 x plus 1/4 times 2 sine x cosine x. And the final answer is 1/2 x plus 1/2 times sine x times cosine x plus c. Now, we can now, since we know integration by parts, evaluate this integral also by using integration by parts. So let's do that. This is integral of cosine squared x. We'll write it as integral of cosine x times cosine x. And using integration by parts, we'll let u be one of the cosines, cosine of x. That means that dv is also cosine x dx, and du equals to minus sine x dx, and v equals to sine x. So the integral of cosine squared x dx equals to u times v, which is sine x cosine x, minus the integral of v du. But notice that du has a minus in it, so this will be plus the integral of sine x times sine x, which is sine squared x. Now the integral on the right should be easier than the integral on the left. If we're using integration by parts correctly, it doesn't look that way, but we can use the trig identity sine squared x plus cosine squared x equals 1 to express sine squared x as 1 minus cosine squared x. So now our integral cosine squared x is equal to sine x times cosine x plus the integral, instead of sine square, we'll write 1 minus cosine squared of x. And so the integral of cosine squared x now can be written as sine x cosine x plus the integral of 1, which is x, minus the integral of cosine squared x dx. As you can see, we have the same integral on the right as we do on the left, and the integral on the right has a minus sign, so we're going to take that integral and move it over to the left hand side, but the sign will change from minus to plus. That gives us 2 times the integral of cosine squared x dx equals to x plus sine x cosine x on the right hand side. And now integral of cosine squared x dx, after dividing both sides by 2, equals 1/2 x plus 1/2 sine x cosine x plus c, which is exactly the answer we got when we used the first